In this video, I'm going to talk to you about units of measurement with a specific focus on derived units. So here's an overview of what I'm going to be talking about. In terms of background then, SI derived units are units of measurement derived from the 7 SI base units. And I talked about the SI base units in the previous video. They can be expressed as a product of one or more of the base units, and sometimes those base units have to be raised to a power, so they get scaled by having an index. So for example, there could be seconds squared in there. Now the SI system has special names for 22 of these derived units. For example, Hertz is the SI unit of measurement for frequency. Now in terms of deriving these units, we can actually use the equations that define a particular variable that we want to find the unit for. So let's take the example of Hertz, which I've just mentioned is the SI derived unit for frequency. The equation is that frequency equals 1 over t, where t is the time period to complete one cycle. So we know that frequency is in Hertz, and we just basically put the units into the equation. So Hertz is the equivalent to 1 over s, 1 divided by seconds. So we've put in the units for time. Now if we put this into standard form, we've got seconds to the -1, and so that is the SI base unit equivalent to Hertz. Now if we look at some other examples, we'll take the Newton, which is the SI derived unit for force, and based on Newton's second law, F equals ma, force equals mass times acceleration. Now we know the units for each of these as shown here, so if we put these units into the equation, we now have that newtons equals kilograms for mass times meters per second squared for acceleration. So putting all that together, we can now see that the Newton, the derived unit, is the equivalent to kilograms meters per second squared. Another example is the joule, and for this one we're going to use Einstein's equation, E equals mc squared. So again, E is energy in joules, m is mass in kilograms, c is the speed of light in meters per second. So if we put this into the equation, we then need to square the meters per second, and the way that we do that, we just end up with meters squared and seconds to the -2. And so overall we can see that the joule is equivalent to kilograms meters squared seconds to the -2. Finally, let's take a look at the watt. Watt is the SI derived unit for power. Power is energy divided by time, where P is power in watts, E is energy, and we've just seen that energy is kilograms meters squared seconds to the -2, and time is seconds. So if we put that into the equation, we've now got kilograms meters squared seconds to the -2 divided by seconds. We now need to change the denominator into standard form, so that 1 over seconds becomes seconds to the -1, and if we tidy this up, we get kilograms meters squared seconds to the -3. So we have to add up the -2 and the -1 to bring the seconds all together, so we just see seconds appearing once. Okay, so that's been a video about units of measurement with a focus on derived units. Thank you very much for watching. Please remember to like, comment and subscribe, and I hope you found that useful.